OK, so we can talk, we can see, what can we do? And that's the next thing which you're probably going to learn when we'll be working with LLM models. Most of them right now expose a new way for the models to communicate with your environment, and this is called tool calling. At the screen, you can see actually the agent creating the tool on demand, which later is going to be executed to run some analytical query based on user request. But what essentially you do to make the tool calling inside the temporal, well, again, it's so easy. It's going to be probably the keyword in today's presentation. Because once you tell AI which type of functions it can call, and once you got these functions as a result from AI activity, all you have to do is simply map them to one of your activities or one of your workflows. Why not? Get the result and push them back to the queue. But be careful. What you want to do is to make sure that the message that user sends cannot be sent in between these tool calls. Otherwise, LLM model will die. They all want to get response immediately without any interception. Well, use the blocking mechanism and implement them inside your signal method. It's not that complex. Code, once again, is quite straightforward. All you have to do is to receive the list of tools you want to call, map them to parts of your system, such as activities, maybe other workflows, maybe something else, get the result back, and you can get this result in a sequential fashion. You can get these results in parallel fashion. Temporal provides you abstractions to do that in every language. Get the result back and push them back in a message queue. Easy. Next call that user does or AI invokes will receive responses, and AI will be able to act based on that. So if you have that, you have tool calling, and you have models you can talk. You have models you can communicate and that can look to information, that can execute arbitrary action, and in some cases do retries even by themselves. Like in many cases, AI will notice that tool call does not work. Let me try to do it once again. You might be asking, so what next? What can you do with these patterns? And the question you can ask yourself, do we even need a user? When you're running these workflows, they open you, while many challenges, such as hallucinated tool calls or skipping tool calls, they do open a huge amount of ability to run workflows or agents, in our case, agentic workflows, that will be executing by themselves autonomously, gathering information and writing the solution as they go. The main problem which you're going to have in this case is that while you communicate with agent directly, as a user, you can supervise him. You can say, yeah, you know what? You're doing it wrong. Please try something else. Don't call this tool. Give me information from different part of the system. When you run agents autonomously, you don't have the user. So what you should do, you should replace the user. And what can you replace the user inside the temporal workflows? Another workflow. So in this position, you are going to create your own supervision layer, which is essentially going to play the role of the user. And this supervision layer is going to be responsible for receiving the command. And you still need some kind of trigger, either webhook or user or something else. But based on this command, it will automatically form the first prompt or the first message and task the agent to execute it. The tricky part here is how to evaluate that the agent actually did some valuable work. First thing you might notice in applications like that, and this is a very nasty thing to see, that agents love to loop. Because the moment agent is making a mistake and trying to correct it in a very different way, but still incorrect one, he's going to make 2 error calls. And OK, I'm an agent. I did 2 error calls. It is in my context. Well, what should I do next? Probably make another call because it seems so logical. So what you might see in some cases, that agent will try by calling your tools over and over and over again, especially when tools have been dynamically created, and fail eventually because of the self-destruct. They will simply overpopulate their context and will offload. Well, you just can't do anything. Thankfully, because you run temporal, you orchestrate and you collect all the information about all the tools that AI calls, all the payloads and all the errors. You can implement many mechanisms how to detect that AI is not doing what you want to do. You can do that heuristically by simply looking for the patterns in tool calls and seeing the loops when something happens over and over. Or you can do something more complex and use another AI model or another AI agent to actually look at the result and decide if this agent is faulty or the result has not been done to the purpose. You're going to be creating deeper and deeper